The next panel is entitled The Next Generation of Transportation, so we'll leave that kind of stargazing to our panelists, and our moderator will be Bloomberg New Energy Finance Head of Policy Analysis, Ethan Zindler, and he will introduce the panelists and take it from here. So please give our panelists and Ethan a warm welcome. Thank you. We can hear some Israeli bickering as well, so if they could tone that down so we can hear Ethan, that would be great. Thank you.
Israeli bickering. Okay. So thanks very much, Elliot, and thanks for our panel. I think this is a great session. Here we are now on day 2 of this, and I think we've heard a lot of discussion of the different technologies. We've heard from some policymakers. We've heard from some entrepreneurs and others. I think a real privilege that we have, for the most part, technologists here today who are going to kind of give us a bit of a gut check on what's realistic and what's not in terms of kind of some of the costs of these various technologies today. So from my right, from your left to me, let me just introduce our panelists really briefly. It's Klaus Bonhoff, who's the Managing Director of the National Organization of Hydrogen and Fuel Cell Technology in Germany. Gordon Exel, the Vice President of Sales and Marketing at Westport Innovations. Glenn Schmidt, who's the Head of Steering Government Affairs at BMW Group. And Alan Taub, who's the Professor of Material Science and Engineering at the College of Engineering at the University of Michigan and the former Chief Technology of General Motors. All right, so gentlemen, I find we have an interesting group here. I think we have two companies who are very much invested in particular technologies, and so I'd like to start there and then talk to our other panelists as well. So Gordon, why don't you kick us off? With Westport is truly one of the leaders right now in terms of thinking about engines that use natural gas. So talk a little bit, if you could, about your company and the activities that you're undertaking right now in this space and the future that you see for CNG, LNG, and for vehicle transport in that area.
Sure. Well, maybe first I'll open with a thank you to Bloomberg and to you, Ethan, for inviting us. We're very pleased to be here today. My name is Gordon Exel. I'm with Westport. As Ethan said, Westport is I guess first and foremost, a technology company. We're Canadian-based, started about 20 years ago based on a technology that was being developed at one of the universities in Canada. Our goal as a company is to shift transportation from a reliance on petroleum-based fuels to gaseous fuels. And today, a lot of that discussion is really natural gas, just because of what's happened over the last 5 years with the shale plays in North America and around the planet. The way we do this is through partnerships. So we're a technology company. The fastest way to market would be aligning with key OEMs and distributors in regions. And so that's what we do. We are privileged with the ability to be able to talk to most key OEMs on the planet. They're very interested in what's happening in the gaseous fuel space and are interested in talking to us. So we've had that opportunity to talk to them, and we've formed some key partnerships with OEMs for brand new vehicles, both in the light-duty sector and in, maybe more importantly, in the heavy-duty sector. And then we've got 2 key joint ventures that actually develop engines. One is with Cummins, which is a very large North American, well, global, but a lot of the product that we build is in North America, so the large diesel engine manufacturer. And a company called Weichai in China, which you may not know this, but Weichai is the largest diesel engine manufacturer in the world today. And our joint venture with Weichai develops domestic product for the Chinese market, and we can't keep up. That market, as you've already heard, is really taking off. From a market perspective, we have about 100,000 heavy-duty engines in service today, mostly in new vehicles, so that would be, from a heavy-duty perspective, probably the path to market. And then probably about 1 million light-duty vehicles in service today, and most of those would be conversions. So we've had some discussion about conversions today, so this would be CNG and LPG as a gaseous fuel as well, but most of those are CNG around the globe. We've worked in different countries and found that there's a lot of different ways for a country to make a move to natural gas. You'll see countries like Argentina or Pakistan that have huge populations of light-duty natural gas cars, and that's how they opened their market. And then you'll see a shift from light-duty, I think, to medium-duty buses and heavy-duty trucks eventually. The U.S., we've talked about that here in the last day or so. The entry there has been heavy-duty. So buses first, and now there's a real move to truck, a shift from CNG to LNG in that marketplace. So there's different ways of entering. We're set up to enter in any way that that market wants to move. So if a market wants to move from a conversion perspective and take existing vehicles and convert them to run on natural gas, we can support that through distribution networks, or new vehicles, and make sure that there's OEM availability with natural gas engines to be able to be sold to that marketplace.
Thanks, Gordon. Interesting comments, and I'll come back to you. I'm curious about the entry strategy and the fact that some countries have started with light vehicles and some have started with heavier vehicles, and why that might be, and what that might mean for a place like Israel, and of course the U.S. and Europe as well. But let me move on to Glenn from BMW. Glenn, if you could tell us a little bit about BMW's strategy in terms of new technology. I think we're sort of lucky that we're catching you at a good moment. I know that there's a new vehicle coming out. It's getting a lot of attention. So certainly tell us about that, but also more broadly about BMW's strategy in terms of new kinds of fuels.
Okay, great. Thank you for the words of introduction. It's also a pleasure for BMW and for us to be here attending the conference. I guess the realignment, let's say, of our alternative strategy, mobility strategy, goes back to the year 2007, where we reworked our corporate strategy with a strategy called Strategy Number 1. And what we basically did at that point in time is to kind of, just to make it clearer for us, reduced, let's say, our strategy to two elements. And one is evolutionary, and the other is revolutionary. And our approach is really to take both of these pathways and to work on both of these approaches at the same time. We introduced a phrase that I think many of you may be familiar with, efficient dynamics, the whole notion of increasing the efficiency of engines, efficiency of our vehicles, but at the same time making sure that they're dynamic and they're still fun to drive. And just maybe to throw a few numbers out there, in the European context, between 1995 and the present, we've been able to reduce CO2 output or fuel consumption of our average new vehicle fleet by over 30%. And that's with conventional technology. And efficient dynamics really doesn't refer to one technology. It's a whole symphony of different types of technologies that work in all of our vehicles. Lightweight materials, new engine technologies, start-stop automatic, a whole bunch of things. But there is a point in time, and it's really the law of physics, where you kind of come to a limit in terms of it being able to improve conventional technology. I always refer to this kind of 80-20 rule, which I learned in school, which applies to a lot of things in life. You know, with 20% of the effort, you get about 80% of the gains. But in order to get that last little bit, you really need to do 80% of the effort. And that really kind of leads on to the next part of the equation, which we've been working on. And that's the whole aspect of revolutionary change. And your comments are quite appropriate, because we're actually in the middle of a global launch of our sub-brand BMW i. The first vehicle, the BMW i3, is being launched globally right now as we speak. And what we've done here with this vehicle is we've taken a revolutionary, radical approach. We've kind of redesigned the entire value chain of how we make cars, how we think about cars. So just to give you a few examples, we have a completely new vehicle architecture, referred to as Life Drive. We no longer have a steel frame in the car. We use a carbon fiber reinforced plastic passenger cell, which radically reduces the weight. It's a fully electric car with a range of 160 kilometers. We refer to this car internally as a mega city vehicle, as a solution for urban transport challenges. And in terms of reducing CO2, we've even looked beyond the car, and we've looked at the production process. And we, for example, use hydroelectric energy to produce the carbon fiber. We use wind energy to produce the vehicles. So it's really kind of about this unrelenting search to reduce CO2. And maybe just to conclude the opening remarks as well, there's a lot of black and white discussion in terms of what's the right technology and what's the right way forward. And I think the honest answer is that in the future we're going to have a pretty broad and diverse portfolio in terms of drivetrain. We're going to have internal combustion engines, be they diesel or gasoline or biofuels, which will need to be optimized. We will have hybrid technology as a bridging technology, but we will also have an increasing number of electric vehicles. And from our perspective, in the near to midterm, electric vehicles are the way to go. We've seen through our field trials that the technology is being embraced very widely. Electricity is everywhere, so installing the infrastructure is a challenge, but it's a challenge that can be solved. And it's zero tailpipe emissions as well. So from our perspective, we're focusing very heavily right now on the market introduction of our electric vehicles.
Great, thanks very much. I do want to come back to you. I've seen the pictures of the i3. It looks really sweet. Of course, I am curious as to how much money it is, given that it's a serious luxury vehicle. I think it's catering to a certain audience. So I'd like to come back to the role of, I would say, high-end consumers in driving the kind of technology change that we're seeing. But I want to shift over to Alan and give Alan a chance for just a moment to talk a little bit about your research. If you could tell us a little bit about it, but also I thought Glenn raised an interesting question about sort of squeezing the last bit of efficiency out of the existing technology. Certainly welcome your comment on your thoughts on how much there may be left to go on that, or if we're reaching the end of the road on that.
Well, first, thanks for hosting the forum. It's been interesting. The perspective I'd like to put on the issue we're really addressing is what is personal mobility, and in particular the propulsion system, going to look like in this century. I mean, if you take a look at the first 100 years of the industry, we're going there because we're in a very similar portion today. It took about 20 years, the first 20 years of the industry, for what we tend to call the DNA of the vehicle to be set. There were aluminum vehicles, there were hybrid vehicles, there were electric vehicles. Most people don't know that. But we centered on the right value equation for the consumer, which was the internal combustion engine in a mechanically driven vehicle. My personal view, as we're in the second century of personal mobility powered today, we're going through that same 2-decade experiment. I think in agreement with prior thing, there will be no single solution. The challenge we have collectively as an energy and an automotive producer industry is how do we handle the complexity of the infrastructure and the propulsion systems that are going to be put into commercial production during this next 20-year period, while we're going through the learning of which is the limited set that will in fact be the right solution. There will be no single solution. The idea of another 80 years of a single energy source and a single combustion technology, I think, is behind us. But collectively, as society, as companies, as governments, we have a limited capital that we can invest. So the way, at least we've thought about it is we have multiple energy sources. How do we get down to a limited number of carriers for that energy? And the way we see this playing out, I think consistent with what you've heard, there will be the continuation of liquid fuels, but the source of those liquid fuels will diversify with the introduction of gaseous fuels. And what happens with those, and limitation is, to your question, we are reaching for today's internal combustion architecture the limits of this. Depending who you ask, there's maybe another 10% efficiency to be gained. You need alternate architectures or fundamentally the shift to electrification. The one point I want to make relative to that before I finish is I tend to think of electrification as the wheels are powered by motors that are driven by electrons. Those electrons can come off the grid, or those electrons can come through fuel cells and hydrogen on the vehicle. So in the end, what we see is the carriers converging to hydrogen, grid, electrons, gaseous fuels, liquid fuels, and what we need to do is collectively get to a limited set of those. So the propulsion systems and the capital investment for the energy infrastructure don't take personal mobility out of affordability.
Thanks. Well, you very kindly set me up perfectly then to turn over to Klaus to talk a little bit about what's happening in Germany. And I know that your organization is very much involved in fuel cells, but other technologies as well. But maybe for the benefit of the audience, talk a little bit first, if you could, about fuel cell technology to fill everybody in, since I think we've heard so much in the last 2 days certainly about methanol and LNG and CNG. But tell us a little bit about fuel cells, but then if you would, talk a bit more about your organization. We heard yesterday a little bit about the efforts underway in Germany to use hydrogen as a power storage technology, so I'd like to hear about that as well.
Yeah, thank you, Ethan, for the introduction and also for organizing the conference here. I think it's a good opportunity to exchange globally on what alternatives we have. Our name indeed is a little bit misleading. We are the National Organization for Hydrogen and Fuel Cells, and that was our founding purpose at the time, to run that national program in Germany. In the meantime, we also run a second program on battery electric mobility. So the German government is substantially funding sustainable mobility, and in our programs we're focusing on those two fields, batteries on one side and hydrogen fuel cells on the other side, understanding that both are needed, so they're not in competition one to the other, but they're actually complementary one to the other. And our organization is set up as a public-private partnership, if you want to, so we are the program management organization, making sure that what industry, academia and government plan to do is actually implemented the way they planned it. And we are the networking knot, if you want to make sure that we coordinate it, prepare those markets, prepare markets for battery electric vehicles and for hydrogen and fuel cells. And the two large programs that we have are in the order of around about 60 to 80 million euro funding per year, around about 200 individual funded projects per program. So it's a nice sized program. And it does include all of the industry, supply industry, automotive industry, but also the infrastructure side and the energy industry. And I think that is key. And really, we are not a classical R&D program, but we do mainly large-scale demonstration in order to test the complete system, to understand the barriers to commercialization, to reduce cost, to increase reliability, to look at technical issues, but also to look at safety, to look at regulations, to look at, in the end, also infrastructure. When we talk about alternative fuels, yesterday we've heard a lot about independency of oil, which of course is important. In Germany, we do import yearly oil at a value of around about 60 billion euros. So that's substantial. We don't have any own large fossil resources in our country, so we need to find alternatives to that. And I think it's a good way to think about alternatives where you have domestic energy sources, which in the end is renewables, and where, of course, you have also domestic technology to deploy those renewable energies. So long term, and that was mentioned earlier as well, we need to get to a mobility mode where we have zero emissions along the whole chain. So zero tailpipe emission is important. And when we talk about the fuels, one of the key points is to use as less fuel as possible. So you can't talk about fuels without talking about the efficiency of the drivetrain. And when we look into the efficiency of the drivetrain, electrification is the way to go. We heard that. And that's through batteries and that's through fuel cells. Now, we see the first commercial battery electric vehicles in the market. We have hybrids, we have plug-in hybrids, but pure battery electric vehicles are coming into the market, like the i3, but also others. On fuel cells, we have OEMs that are starting to introduce their vehicles in 2015. Toyota has announced, and they will show that vehicle this year at the Tokyo Motor Show, they have announced that they will commercially introduce a fuel cell vehicle. Now we see large cooperations or large collaborations between companies. BMW is partnering with Toyota. We see Honda working with GM. We see Daimler, Nissan, and Ford have formed an alliance. All that is to reduce the cost, to make sure that you can actually introduce fuel cell vehicles at a price that the consumer is willing to pay. So cost reduction is one of the issues here, of course. And then when it comes to the energy for batteries and for fuel cells, really the key challenge is how do you get renewable energies into that? And here we have a specific situation in Germany. We already have 25% renewable share in our power sector. We're not used to looking into the power sector, the transportation sector as an integrated energy system, but that's exactly what we need to do. If we see an increasing share of renewables, which are fluctuating energies, we will need storage, and putting the electrons directly into the vehicles or storing the electrons via hydrogen is a good thing to do. And all of a sudden you have a renewable fuel that can be put into the transportation sector. And indeed, this is the power-to-gas concept, as we call it in Germany. If you look at the economies of that, you have a hard time to find a good business case if you look at the power sector alone. But if all of a sudden you add transportation to the equation, you get to viable business cases, including building the infrastructure, building hydrogen stations. There is a viable business case with a downside that the first 5 years are a loss-making business. And that's the challenge that we have to jointly address.
One question I certainly have to raise, though, which is that we talk about using electric vehicles, but if you have low-priced natural gas available, and I know that's not every country, that's the United States, clearly becoming Israel, other parts of the world as well. Why do electric vehicles? Why not simply use the gas as a fuel, put it in the tank, and go that way? What's on a cost basis? Isn't the more direct route just to use the gas as a fuel?
Well, I guess that's the dilemma we're in. You're right. If I have cheap gas available and I have an internal combustion engine that is affordable, why not do that? You save, what, 20% over the cycle as compared to diesel or gasoline vehicles. So, yeah, that's a viable strategy. But at the same time, we have longer-term goals. Ultimately, we want to get all of the emissions out of the mobility sector. So even if you base that on natural gas, why not use it more efficiently, even if you transform it to hydrogen, than in a fuel cell drivetrain, which has double the efficiency of an internal combustion engine. So well to wheel, you save another 10 to 20% compared to a natural gas internal combustion engine. Now, we don't have affordable fuel cell vehicles in the market today, but that doesn't mean we don't need them long term. We do.
Is that a function of the technology development, or is that a function of scale?
Today, really, it's basically a function of scale. I mean, still, the engineers and the scientists, of course, are challenged to find alternative materials to, reduce the complexity of the system. All that is true, but DOE has done some, or is doing constantly, very detailed analyses of the cost of fuel cells. Fuel cell technology today, built in volume, i.e. 500,000 vehicles per year, would already give you a cost of $40 per kilowatt. So that at a 100 kilowatt system would give you $4,000 for a fuel cell drivetrain. So we don't have the volume, so they are much more expensive. But even with today's technologies, you can get to those costs.
So one area where at least according to our research, we are seeing volume and economies of scale has been in the production of lithium-ion batteries. And the fact that there was, frankly, it's been an interesting development in terms of electric vehicle rollout. A lot of the OEMs made very bold claims 3 years ago about how many of these things were going to get sold. It didn't happen as quickly as many had planned, including GM and others. And we have this overcapacity in terms of more battery manufacturing than the world has needed. That's maybe bad news for battery makers, but it's good news for consumers. So Alan, maybe if you could talk a little bit about where, are we going to see a drop in electric vehicle prices as a result of that, or is this a more nuanced story that I'm sort of painting?
Yeah, I think the point you made earlier, the improvements we're going to see in cost, which that means translated to lower price to consumer, today has been dominated by scale. When we began the electrification about a decade ago, you were looking at, say, in batteries, $1,000 per kilowatt hour, and interestingly enough, about $1,000 per kilowatt on a fuel cell. The march to have that to the $500 kilowatt per kilowatt hour in the case of batteries has been some chemistry, but a lot of that has been scale. The key is, let me refer to the DOE targets as well. What do you need to do to make these systems economically competitive in the hands of our consumers for their cost of personal mobility. Most would say the batteries have to break, and forgive the U.S. units, 250, somewhere between $250 and $200 per kilowatt hour. The march to 300, I think the technology roadmap has been established. But as my colleague said, it's that last 20% that's the slogging. In the case of fuel cells, you know, it really is going to boil down to, and I come back to, we need the best technology. We need the smartest public-private partnership, where the private is now the automotive companies and the energy companies together, to walk down both of those curves, not to select winners at this time because of the technology uncertainty, and do a cadenced and consistent introduction of the infrastructure and the vehicles. You know, to conclude, a point I would make is the reason you're seeing the battery electric vehicles commercialized about 5 years ahead of the hydrogen-powered fuel cell is because for limited introduction of the plug-in, there was not an infrastructure change required. What paced the hydrogen fuel cell introduction of vehicles was the need for a simultaneous energy infrastructure in that. You will see these play out, and the key is it would be very easy for the automotive companies to say, well-to-tank energy companies, go ahead and give me liquid fuels that are diversified, and I will stay with my inefficient utilization of that fuel. We have to do partial and full electrification to get the use of the fuel high.
So it's a chicken and egg thing is partly what's been holding up on. I mean, it helps to drive technology adoption. So whatever, if you don't have a chicken and egg, you know, if you can get juice out of your garage like I do for a Leaf or whatever, then you can. Then you'll see faster adoption of technologies, even if they aren't necessarily the most cost competitive.
I'd say the more you have to involve a different supply base, the transition to carbon fiber, you know, for lightweight materials, the more you need to develop and integrate the energy supply base. It takes longer to get coordinated action. But at this point, the world is ready for that transition. And again, I really think it's going to take a public-private partnership to drive society to solve its sustainability problem. And as people have said, during this time period when we will be otherwise increasing personal choice to do that.
So Glenn, I would come back to you for just a second in terms of personal choices. You know, the vehicle you just mentioned reduces 160 kilometers. Is that the?
That's right. So
how does that? Where does that leave consumers in terms of this question of range anxiety? It strikes me that it's an interesting number. It's a bit higher than some and a little bit lower than others. Do you think that addresses people's concerns, and is it falling some sort of sweet spot at 160?
Sure, yeah. We've actually conducted pretty extensive field trial research leading up to the BMW i3. So we had a global fleet of electric Minis and electric 1 Series as well, which are conversion vehicles. The BMW i3 is a purpose-designed vehicle just for electrification. But what we found is with this range of 100 miles in the U.S., 160 kilometers in other markets, that you really have a range that can cover about 80 to 90% of all driving behavior. So if you're somebody who spends most of the time on the Autobahn and you're driving long stretches, then obviously driving an electric vehicle is going to be a bit of a tough call for you. But if you look at driving patterns, and we have a lot of objective information that we were able to gather, the average driving distance in Germany, for example, is 40 kilometers. The average driving distance in the United States is a little bit more. It's maybe somewhere to the magnitude of 55 or 60 kilometers. That's all well within the range of an electric vehicle. And the common driving behavior is I drive during the day, this distance, I park my car in the evening, at night, and I charge the battery. And the battery is 100% full the next morning and you're ready to go again. Of course, there are other situations where the range is not sufficient, and there are solutions for that. One solution, for example, is to have a range extender. And the BMW i3 will have a very efficient two-cylinder engine that kind of acts as a reserve tank just to charge the battery. It's not powering the wheels of the car.
So just so I understand, does that mean if I get to the end of my 160 kilometers and I'm on the Autobahn, does that kick in and I can keep going, or do I have to stop and then it recharges?
It just continues. So once your battery hits a certain low level, then it kicks in to keep that level of the battery stable, and then you can continue driving to the next charging facility. The other solution is to have a public charging infrastructure of rapid chargers, DC chargers. So it's possible to charge a BMW i3 from 0 to 80% within about 30 minutes using 50 kilowatt rapid charging. And then the BMW i3, for example, is also multimodal. So that's an innovation in itself as well. If you're asking the navigation system to go from A to B, and you can't do it with a car, then it's giving you alternatives as well to take public transportation. Or it may be, for example, that there's a traffic jam, and it may be more efficient to be driving your electric car to a charging station, parking it there, charging up the car, and then moving on with public transport. And ultimately, at the end of the day, if a customer says, I need to 2 or 3 times a year have a 5-seater vehicle with a lot of trunk space, I'm moving my family big distances, then we'll even have a flexible offering for customers so you can trade in your i3 for a conventional vehicle.
Oh, okay.
So I think for every critical question, there's also an innovative answer as well.
Well, actually, I have to come back to this question then of charging stations, because I think there's certainly been some high-profile examples of independent third-party companies that have tried to do, without naming names, that have tried to run charging stations and make that a business model on a standalone basis. Is BMW going to get involved? And certainly in the U.S., Tesla's made a lot of noise about trying to build charging stations along key corridors like the I-95 corridor on the East Coast. Is that something that BMW is going to get into doing as well?
Yeah. I mean, I think one thing that we realized very early as well is that it's not sufficient from a manufacturer perspective just to hand an electric car over to a customer and say, you take care of the rest of the things. So we need to take responsibility for that. And one thing that we will do with the BMW i3 is offer domestic charging infrastructure and also work with local partners for the installation, for the inspection process as well. So that's one big hurdle. And I think a lot of initial customers will be relying on either a work or a domestic charging infrastructure. And one of the big learnings for us was if you want electric mobility to work, you need to have one reliable charging source that's yours. So you don't need to initially have a vast public charging infrastructure. And in terms of public charging infrastructure, we are offering some things. We are working together with a lot of local partners. And one thing that we do is we offer a Charge Now card to our customers that allows our electric vehicle users to access as much public charging as possible, because you've got many, many different providers out there with different forms of billing. So we try to link all of that together so that as an EV driver, you can access all of this public charging infrastructure. We have publicly funded projects, for example, in Germany, where we're installing a rapid charging corridor along highways. And ultimately, it's been mentioned a couple of times as well, you need to have a business model based around these quick charging. And there has not been a final definitive answer to that question as well. That's something that needs to be worked on.
Ethan, I know Terry's got a question over here he'd like to throw in, if that's all right.
If I may, this panel has done a great job of, once again, teeing up the choices of fuels. But it's just started to tease the question that I think we've got to get into, which is what we're doing about the vehicles themselves. And what are the barriers to making them more efficient? Because they still are largely made by metal. I think Alan or Glenn mentioned that we're starting to make them out of carbon fibers, make them lighter, much more efficient. But unless we really do that in a serious way, as serious as we're talking about all these different fuels, we're going to keep wasting whatever these precious fuels are that we're spending so much money to try to develop. So I'm wondering if the panel could address that issue of how do we get these vehicles more efficient and what are the barriers?
That's a great question, though. I do want to, and I want everybody to get a chance on this, but I do want to actually first point it to Gordon, because, I mean, when we talk about natural gas, do we need to do a lot of overhauling of an engine or of the fundamentals of an automobile to achieve a higher level of efficiency on a power basis?
Well, that depends. Let me start with saying that natural gas is more difficult to ignite than petroleum fuels. So it's harder to ignite than gasoline. It's harder to ignite than diesel. So in a compression ignition engine or a diesel engine, the technology is challenging. So there are simple technologies today that will get you, that you will pay for from an efficiency perspective. They're just not as efficient. They don't give you the economics, but they're simple and low cost. To extreme technologies that will get you to compression ignition capabilities, performance, efficiency, power density, and that's the goal. So, you know, kind of looking at the question about the vehicle, we're going to let the OEMs work the vehicles. When we partner with an OEM on a natural gas strategy, we will line up with their diesel product or their gasoline product and say we will be within plus or minus 1% of what you're delivering on a liquid fuel. So the challenge really is technical. It depends on what you're doing and on what engine platform you're doing it on. And that's why you see markets shift differently. You'll see markets enter based on a very simple, easy technology, let's get in quick, or markets like the U.S. that is investing in heavy-duty, high fuel use fleets, having a big impact on crude use to have an impact on energy security. So it varies.
Yeah, and then didn't mean to cut you off. Go ahead.
Yes, so let me address your question. If you start with 100 units of energy in a fuel tank, and you deal with today's internal combustion engine, 2/3 of that energy is lost as heat, and only 1/3 leaves the shaft as torque. That's why we're talking about the need to hybridize and electrify, to make that efficiency better in the propulsion system. You lose another 15% between idling and drivetrain losses. You're now down to the energy getting to the wheels. And the answer is you have to improve 3 dimensions. 1/3 of that energy is lost as rolling resistance, where you're heating the tires in the pavement. So we need better tires. Aerodynamics loses another 1/3. And so we need better designs. And smaller vehicles, but clearly are better. And the other 1/3 goes to move very heavy vehicles. So the challenge is not just weight, it's better packaging, lighter weight, better rolling resistance, better aerodynamics. And I think you're seeing the various automotive companies move on all fronts, including, as we talked about, shared mobility, alternates, so that you're not buying as an individual the largest vehicle that you need for the 1% of the time you use that during its ownership. But because it's so affordable, that's what I choose. And therefore, I carry that inefficiency. So it's a change in the business model. It's a change in the way owners think about how they move themselves, and clearly better engineering solutions on the vehicle.
Yeah, that strikes me as much a challenge, a marketing challenge, or trying to transform consumer perceptions on these issues. And actually, one question along those lines, are consumers changing in terms of the way they perceive these? I mean, that 1% view, that I need the car that will get me from my house to, wherever, North Carolina, or, that younger people, they seem to have a different perception about wanting to own a car, or if they do own the car, what that car is supposed to do. Is that going to change the automotive market in some fundamental way?
I think what you're seeing in, say, the Envy concept vehicle General Motors had at Shanghai, what you mentioned is, it'll be partially generational, but I think that reinvention will be driven by the megacity of the world, where the problems of emissions, environment, energy availability, and then you add safety, congestion, parking, are converging faster than any place else. And so that's likely to be the environment where owners of vehicles start to modify their behavior and will make more choices available. For the rest of the community in the world, I think it will follow. But I personally believe it's the urbanization phenomenon that will be the place where the new architecture for mobility comes in.
I think this is a really important point that we can build on as well. I mean, there's been a lot of discussion about the drivers for sustainable mobility and for biofuels and alternative solutions, legislation, convergence of law, these sorts of things. But I think one of the key points is also getting the consumer involved and excited. And you mentioned actually a lot of valuable points concerning electric mobility. If you try an electric car, you're fascinated by the torque.
Yeah.
You're fascinated by the fact that it's almost silent. You're fascinated by the fact perhaps that you never need to go to a gas station again, that you have that freedom to move. And an electric vehicle can also be an enabler to connect your car to a lot of other services as well. So getting the consumer involved is really important. And some of our EV users in California, for example, Americans, are always very excited about new technologies. They coined the phrase EV smile. Try driving an electric vehicle and you get out of that vehicle with a big smile on your face. And think beyond legislation and beyond this discussion about finite resources, get the consumer involved. Take a look at, for example, the iPhone. People love iPhones because of the functionality. It's redefined the way we communicate. Nobody presents their new iPhone and talks about the lithium-ion batteries inside of them and that they've got the newest generation. It's the functionality and the benefits around that that's in the foreground. And I think ideally that's something that we should strive for with new technologies as well.
I think I don't have enough time to ask a new question, but I'd certainly invite the panel to any final comments on these or other topics before we close.
Well, I think it is important to look at the business models. You have to convince the consumer. He needs to understand why we need a change. We do need changing the system, the way we use mobility. But really the business models are key. You talked about the challenge of fast recharging infrastructure. Is there a case for it or not? We need to find that out. But until we find out, there are a lot of customers that want to have those vehicles, and they recharge at home or at work. Talking about hydrogen, we have started in Germany, but also in other places around the world, public-private partnerships to get the infrastructure in place. We know we can do it. We know there is a business case. But hey, let's overcome that first hurdle of not making money the first years.
Great. Well, thank you so much to our panelists. A really interesting discussion. It sounds like I think that maybe the first conclusion I heard is probably the best one to sort of end with, which is that there's sort of no one-size-fits-all solution to this, and it depends a lot on local conditions. But I think we could all agree that conditions are changing rapidly, and there's all these new choices emerging. So thanks so much, everyone. Much appreciated.